Hi, this is Blackcore Mathematica. Uh, we are going to talk about Interstellar in this lecture. There is so much interesting stuff in Interstellar, and I will talk about the wrong explanation about physics in Interstellar, and a lot of interesting stuff, like special relativity. I'll talk about that fact in this lecture. First, I will talk about this scene. In here, director puts Murphy for main character, and it is for Murphy's law, which means there's destiny. Well, this is not physics, so this is out of our way. Next, let's see this mummy.
The ghost.
This is information from future, but this is not right, because no information is faster than light. And gravity is not faster than light, so gravity cannot have a time travel. Uh, this is an information from future, yeah, using gravity. I can control other force like electromagnetic force, because ADCST correspondence makes it possible. But this works only in black hole. But there is no black hole in that room, so it is not possible. Without black hole, grand unified theory doesn't work. And also, sending information with gravity cannot be discrete like this, because it is small and the delta force per distance is very small, so it cannot be discrete like this. And there is no black hole in that room. If there is under black hole, the the density of air should be bigger than water. This can be possible. There's sixth sense, which is recorded in organs, so prediction for future can be possible. For example, when someone experiences horror event, his gut has that memory, and it has same effect when he experiences similar experience. That is why elimination of vagus nerve prevents colon cancer. So she can predict future with sixth sense. Let's see the next thing, and we have another thing. It is possible to have a wormhole. If we have two entangled in black hole, we can experience wormhole as we pass it, but we cannot make a black hole past. That is impossible. But the graphic is so good, so just watch it. As gravity gets stronger, time goes slower. As velocity is faster, time goes faster. And when gravity is strong, the velocity gets stronger because the potential energy equation is minus kV when k is constant. So, as potential energy gets strong, velocity gets strong, so as gravity gets strong, time gets slower. As velocity is faster, time goes faster, and when gravity is strong, the velocity gets stronger because the potential energy equation is minus kV when k is constant. So, as potential energy gets strong, velocity gets strong, so as gravity gets strong, time gets slower. The singularity is very fascinating. This is the reason for why black hole is homeomorphic with infinite structure. And black hole has duality, so is singularity. So, black hole can be particle and wave at the same time, and singularity can be wave and particle at the same time. If black hole is Bella, singularity is Bella with mystery. In this scene, this H is Hamiltonian. This is to calculate energy of fields. This H, she, let's see next scene.
Attempt to prove its own proof. It's recursive, it's nonsensical.
She says need for definition of time, but definition of time is proper time. With proper time, we can make good definition of time. As we integrate proper time, we can get trajectory of particle.
The equation couldn't reconcile relativity with quantum mechanics. You need more
what?
more data. You need to see into a black hole. The laws of nature prohibit a naked singularity.
Not only is that true, if a black hole is an oyster, then the singularity is the pearl inside. The gravity's so strong, it's always hidden in darkness, behind the horizon. That's why we call it a black hole.
Okay, but if we see beyond the horizon,
We can't.
There's some things that aren't meant to be known.
Gravity equation and quantum mechanics are entangled in black hole. This is called duality or ADS-CFT correspondence theory. So quantum mechanics can explain gravity, and gravity can explain quantum mechanics inside black hole. But unless we get into black hole and estimate data about singularity, it is not possible to research.
yes. Hey, Dash.
Well, can you make a Morse code transformation? Yes, we can, and we can decode information of black hole near surface of black hole. So, if we can get close to black hole, we can get the data because we can decode the gravity loop near the black hole, which makes shift 5 dimension. Well, this information transformation from future to past is not possible as our intuition. This is only possible inside black hole, but it is too hard because black hole has a density bigger than water. But it is quite impossible to move in black hole. This is possible. Contact between black holes can be possible even between past and future, but only inside black holes.
This entire facility is a centrifuge. Some kind of vehicle.
This is wrong. Gravity without information of matter is impossible. We cannot control gravity.
Plenty of slaves for my robot colony.
I gave him a humor setting so he'd fit in better with his unit. He thinks it relaxes us.
This is a conversation between AI and human. I think AI would be smarter than humans, so AI would do human work instead, I hope, like lawyer. Because AI only takes electronic power and it doesn't need complex mechanisms for energy intake.
life. Laura Miller's planet is first. Laura started.
Hibernation is important issue. We can't have biological time travel with hibernation. This picture is wrong. Because region near black hole is so bright that the spaceship cannot be dark like this unless it is orbiting black hole.
In love with Wolf Edmonds. Is that true?
Yes. And that makes me want
There is a love issue. Entangled information is conserved even though two particles get farther. And if we see brain as a particle and define love as entangled, we can say love doesn't change even the couple gets farther. I like love theme.
Observable, powerful. It has to mean something.
Love has meaning, yes. Social utility, social bonding, child rearing.
We love people who have died.
I hate it. Yes, we have to worry final consumption of oil. I think direct get investment from oil seller. This is about worry for fast development of science, but we don't believe it since 2015 when Marvel movie get popular. So, we've been learned about Interstellar, and there were so many lovely themes in this movie. So, if you are a physicist or if you work in physics department, I think this movie can be fascinating because there is so much beautiful scene and beautiful uh, photos. So I highly recommend this movie to any guys. Uh, so thank you, my friend.